At runtime, we can swap between these two modes, streaming thousands of actors in and out, and enter into the dark world. Let's see this in action as we go back to Chant.
Thanks, Galen. Many runtime and interactive frameworks in Unreal Engine are getting significant updates in UE5. One thing we've added for animation is an experimental new full-body IK solver, which is designed to give you better results with less work. Here, you can see it in action as the rig for our player character, Echo, corrects itself to adjust for variations on the ground below. Gameplay systems. We've also added a new framework called Game Feature Plugins that will allow you to build and ship game content in a more modular way. With Game Feature Plugins, numerous core gameplay features can be built in parallel with better encapsulation and finer content organization. Game Feature Plugins allow developers to add activation instructions to extend base game functionality, register new input actions for players, and interface with other frameworks such as animation. When we shifted into the Dark World, we also activated a new game feature to give Echo a brand new attack ability. All of the assets and logic needed for the ability, including new animations, input controls, blueprint code, VFX, and audio, are contained inside this plugin, and core game classes have no idea that these assets exist until we activate it. We've also added a feature called Animation Motion Warping, which allows you to manipulate root motion animations to adapt them to the world. Echo's vault animation was authored to the specific dimensions of this rubble. Like these pieces of debris, by sending information about their size into the motion warping system. Before triggering the vaulting animation, a blueprint script determines her rotation, how high up she jumps, how far she needs to move to get to the other side, and where her feet should land. Motion warping then adapts the root motion of the vault animation to match this data. So on the topic of animation, Unreal Engine 5 also includes our in-editor rigging tool, Control Rig. Meet the Ancient, a film-quality creature imagined and built by our friends at the Aaron Sims Creative Company. We partnered with Aaron Sims and his group of talented artists to concept the Dark World and to bring it to life through an enormous mythical adversary. While imagining the battle between Echo and the Ancient, we wanted to give the creature a heavy laser attack that Echo would have to avoid. We needed it to track Echo's location in the arena and fire a slow, sweeping blast towards her. Here is what the base firing animation looks like. And here it is again, with the full body IK post-process layers enabled, and our info about Echo passed into Control Rig. With full body IK and Control Rig, designers and artists can now author fully dynamic animations that react to gameplay without having to build complex animation state machines composed of numerous animation assets. Alright, let's take down the Ancient.
There's Echo, who we saw last year, right?
That's right. We've got her sitting here at a campfire outside in a large photorealistic environment that was built with photo-scanned assets that are in, I don't know how many exact polygons we have in this scene. Galen, do you have any idea?
Well, so we have millions of instances actually in this environment, and each individual asset that makes up the environment weighs in around 2 million triangles, which is an absolutely staggering number compared to what we were pushing around for last gen. So it's very exciting from an artist perspective, being able to just have so much more detail than we ever had before in Engine. So.
Yeah, and so her moat here is used kind of as a drone to kind of explore some of this space out here and kind of get really far out. We can fly all the way into any of this, and you'll see that it's, depending on where all you go here, or wherever you go, I should say, it's all the same level of fidelity that you'd see up front where she is. So using Nanite allows us to get all these things in there, all these assets in there at just really crazy high fidelity, like we've never seen before, as Galen mentioned.
Yeah, and one thing that's really cool about this environment specifically is that we actually went on location in Moab, Utah, to actually go and actually source all this data. So all the assets that you're seeing here, we photo scanned out in the desert, and we scan with drones. We have handheld setups, all different types of equipment to actually gather that data. And so what you're seeing here is a true representation of kind of basically like sort of an impression of the area that we actually went and scanned in Moab. And the scale is just unbelievable in that area. It's just so impressive to see.
Wow. No, it builds on obviously what you guys showed last year, but now we've got some combat. We've got a real sort of gameplay sequence. And I think a lot of people watched the video and said, wow, that's a game I want to play. And you guys really mocked up this sort of feels like a 2 or 3 minute sequence where you get to kind of go through the entire the combat sequence and everything. So Chance is there. You've got the real controller we can see, and you're playing. Let's take Echo on her adventure.
And so what we're doing right here is actually just swapping into a completely different world, right? So Echo's not moving, her location stays the same, and we're just triggering a basically completely new area based on new materials that you're seeing. So there's transitions with the textures and everything like that. A completely new setup actually for the whole environment. So a lot of the same pieces you'll see are actually there, but she's now walking on a completely new bridge that didn't exist before we triggered the sequence here. So
wow.
That's right. And again, everything here, just like the other environment, it's fully dynamically lit, and it's all using that high resolution nanite content as well. Given her new abilities that she didn't have the previous demonstration as well, using new modular tech.
Wow, and look at, and you see there like the destruction, obviously, of the, so it's, you know, incredible geometry with nanite, but then also, you know, fully destructible, and the environment can change, you know, on the fly too.
That's right. 100% dynamic.
All fully real time, right?
That's right. This creature is also a nanite creature. Every mesh on this thing is, you know, I think something like 50 million triangles create everything he's got there. It's wholly nanite. And we're using some new animation tech to actually, we use new animation tech to build it. We have new animation tech to actually animate it and make sure that it can actually fire at Echo whenever she's trying to fight it here in the scene.
Yeah, and so all the detail on the robot specifically that you otherwise would have kind of projected using normal maps for last gen is actually modeled in entirely, right? So we're just kind of retopologizing much more dense geometry than we did in the past. So if you really kind of zoom in on the robot, you'll see all the different ridges and all the different details that the artists have carved in. It's all there, and it's really cool. You zoom up next to it, and it's kind of like a transformer. There's a bunch of stuff that's moving in there as well. It's a very impressive character that the guys threw together.
Yeah, everything here is running, you know, just in the editor the same way we would build, you know, any of our other games. We're able to test this not just on a package build, but we can pop out from here and do a number of different things that you would do as a developer to kind of, you know, adjust locations of specific things.
I think that's such a key point, is that it's real-time gameplay, but also you guys can actually build and iterate and edit on this in the engine. You said just like pull right out there, so you can in real time sort of tweak things in the environment as you go, which is, I mean, one of the true powers of Unreal, which is amazing that this all can happen at that fidelity. And then artists, you know, Galen, you can go in and then, you know, retexture or paint things or modify the environment in real time, right?
Moab is just such a visually striking place to be. If you ever get a chance to go, I mean, it's just so impressive. The scale of everything you see there is just wild. And so when we're out in the desert, you know, we went and we went and sourced, you know, assets that we felt like would be really valuable for what it was that we were trying to create, you know. So We scan a lot with drones now, so really kind of getting much larger assets than we normally would. And then we also break down environments down to really, really small components as well, right? So literally you'll see things that are the size of several story buildings down to small pebbles and things that we can hold in our hands, right? And that's all the things that we need in order to sort of make a full environment like this. So breaking it down to an eco-region specifically, that's
When setting out to make our demo, we wanted to push the boundaries of what's possible with UE5 today, while targeting next-gen hardware specifications. Here are sequences running in real time on PlayStation 5 and Xbox Series X. Now, one of the main features of Unreal Engine 5 is Nanite, our virtualized micropolygon geometry system that frees artists to create as much geometric detail as the eye can see. Virtualized geometry supports orders of magnitude more triangles without compromising speed, and replaces the traditional system of mesh LODs, handling all detail transitions seamlessly without any additional setup. Now, UE5's new anti-aliasing solution, Temporal Super Resolution, keeps up with all this new geometric detail to create sharper, more stable images than before, with quality approaching true native 4K at the cost of 1080p. While highly detailed assets are great on their own, high-quality lighting that realistically reacts to your scene is what opens the door to more dynamic worlds and immersive gameplay. Lumen is our fully dynamic real-time global illumination solution that immediately reacts to scene and light change, making for more believable experiences. And the GI hooks in directly with our time of day settings, allowing for true physically based setups for photorealistic environments. The Megascans library has meticulously calibrated physically based surfaces and objects in the thousands of assets as of today. And the assets that we're highlighting here show just how powerful it is to have Nanite and Lumen working in tandem. In this example, we wanted a fully dynamic scene, no light baking, and realistic interpolation between the different times of day. In UE5, we are reimagining what collaboration looks like for teams and projects of all sizes. A common challenge when collaborating on large worlds is deciding how to structure map content so that everyone on the team can easily work without asset contention, while also avoiding painful merge conflicts. Now, this approach means you could have artists lighting, set dressing, and reworking the landscape simultaneously, all within the same virtual space. Managing this much content at runtime typically requires a ton of thought about how to stream relevant content in and out to stay inside performance budgets. Fortunately, World Partition handles that as well. At runtime, only the cells in a user-defined radius from our player are loaded, and as we move, new cells are streamed in, while cells no longer needed are replaced by their lower resolution, hierarchical level of detail, or HLOD version. And since all projects have different requirements, the cell size and loading radius are fully configurable to match each project's content streaming needs. Another feature that comes along with World Partition is data layers. Data layers are a way to categorize map assets and collectively enable or
This has to be the right way.
Before we continue, let's stop a moment and take a look at some of the key features of this demo. Much of what you see was built with Quixel Megascan assets, but instead of using the game versions, we used the cinematic versions, which would typically only be used in film. There are around 1 million triangles each, and thanks to virtual texturing, they all use 8K textures as well. Nanite can render an insane number of triangles very quickly. There are over 1 billion triangles of source geometry in each frame that Nanite crunches down losslessly to around 20 million drawn triangles. What does that many triangles look like? This isn't noise. These are the triangles, each a different color. Most are so small that they look like noise. Nanite achieves detail down to the pixel, which means triangles are often the size of pixels. This amount of geometric detail requires shadows to be pixel accurate as well, and Nanite can do that too. Speaking of lighting, all of the lighting in this demo is completely dynamic, with the power of Lumen that even includes multi-bounce global illumination. No light maps, no baking here. Without GI, all of that beautiful lighting is gone. With Lumen enabled, we can move the light and the bounce changes instantly. Okay, let's keep going. We've made some great additions to our audio system as well. Convolution reverb allows us to measure reverberation characteristics of real spaces, like actual caves that we sampled, and reproduce them in virtual spaces. Sound field rendering allows us to record and play back spatialized audio. All of this adds up to a more immersive experience. This swarm of bats was created with our Niagara effects system. Particles in Niagara can now talk to one another and understand their environment like never before. We've also added a ton of new functionality to run fluid simulations like you see in the water below. The demo runs on our Chaos Physics system. Here we are using it to accurately simulate the rigid bodies of the falling rocks and the cloth of her scarf. Now that the environment is so complex, we've needed to greatly improve our animation systems to adapt. We've added predictive foot placement and motion warping, which dynamically modifies IK and body position to look more natural. For the character to more realistically interact with the environment, we've added the ability to trigger seamless contextual animation events, like her hand on the door.
Looks promising.
Dynamic GI is amazing, not just for speeding up iteration, but also for its impact on gameplay.
Nice.
Any light
Looks-
source can move while
it
still
might
having
be.
beautiful bounce lighting. Dynamic illumination means specular as well, which you can see on all the metal surfaces. You can even see the Niagara-powered bugs reacting to the light. Lumen not only reacts to moving light sources, but also changes in geometry. Remember we mentioned high poly assets? This statue was imported directly from ZBrush and is more than 33 million triangles. No baking of normal maps, no authored LODs. And we can do more than a single statue. There are nearly 500 of that exact statue at the same detail level placed in this room, for a total of over 16 billion triangles from statues alone. Over this entire demo, there are hundreds of billions of triangles. So with Nanite, you have limitless geometry, and with Lumen, you have fully dynamic lighting and global illumination, all running on a PlayStation 5.
There's not much time left.
And this doesn't need to be constrained to small rooms. It can stretch all the way to the horizon.
The portal, it's open. Don't fail me now.
time to see what's next.